On this DeBacco University video, I'm going to go over key chemical as well as physical properties of metals, including nonmetals and also metalloids. All right, before I get talking about these in any detail, we should probably know where they're located. And we're going to use the periodic table to do that. First off, metals are this blue area below and to the left of basically this line right here. You can see the majority of elements on the periodic table would be classified as metals. Then we've got our nonmetals, which are basically over here in this tannish coloration. And then we've got the metalloids, which are this kind of stair-step line here. And they kind of are in between the metals and nonmetals, and as you would may imagine, their properties also border between a mixture of metals and nonmetal properties. Well, let's get into some of the details here, starting with our metals and the physical properties of them. They're going to have a luster, which is a shine and reflectiveness due to the delocalized electrons that interact with light. And we can see it here with like the pyrite and gold kind of like look to them, very shiny appearance. We call that term luster. In addition, another physical property is metals will be malleable and be ductile as well. This means they can be shaped or drawn into wires. Because of the metallic bonds that exist, this allows atoms to essentially slide past each other without breaking, allowing the formation of wires. There's also a high electrical and thermal conductivity associated with metals. These are delocalized electrons that move freely, conducting electricity, and also have high heat efficiency. Now, additionally to those, metals can also have high melting and boiling points. And so even though we're looking at wax here, well, just think of this it takes a lot of temperature, a very high degree to basically get these to melt or boil. Now, a strong metallic bonding occurring, this is at the molecular level. The electrostatic interaction of positive metal ions creates what we call a sea of delocalized electrons. Think of that just like a bunch of electrons all around. As a result, this requires significant energy to break through this, though mercury has a low melting point. So again, we're looking at the general properties here for metals. In addition, they also have a high density. Most metals are dense due to the closely packed atoms that we can kind of see depicted in this image right here. Exceptions, some alkali metals like sodium and potassium tend to be a little less dense, but again, we're looking at the majority of our metals. The majority of our metals also are solid at room temperature, except mercury, which is technically a liquid at room temperature. Now, the chemical properties of these same metals, those were just the physical properties. Look at the chemical properties, they tend to form positive ions, meaning they tend to lose electrons. This is due to their low ionization energy. They form basic oxides, so metal oxides. Sodium oxide here reacts with water to form bases that are insoluble. High electroporosity, which is a tendency to donate electrons in reactions, particularly our group 1 are alkali metals, and also our group 2 are alkaline earth metals. They tend to form metallic bonds. It should come no surprise with metals, which are defined as strong attractions between metal cations and delocalized electrons. You kind of see a little bit of an image of that here, as well as just a reminder of where those metals are located. Now we get into our nonmetals. What physical properties do nonmetals have? Well, they tend to be dull and non-reflective, except iodine can have a slight sheen. If we think back to our metals, metals will be shiny. Nonmetals, quote, the opposite. They'll be dull and lack that luster. They're also very brittle, as solid nonmetals can be called crumbly, lack malleability due to covalent bonding. They also are poor conductors. You can think of them as greater insulating properties. They have low electrical and thermal conductivity because the electrons are localized in covalent bonds or molecular structures, not able to really move freely around. The exception here would be graphite to form in the form of carbon that can conduct electricity. But again, overall, most nonmetals are going to be poor conductors or being classified as insulators. In addition, unlike our metals, the nonmetals will have low melting points. Many exist as gases or volatile solids due to the weak intermolecular forces, such as van der Waals, through covalent networks like a diamond that have high melting points. So again, keep that in mind that here, for the most part, many are going to have that low melting or boiling points. They're often going to be less dense than metals, with some exceptions, but overall less dense when we compare them to metals. They can be varied states. Many will be in the gaseous form. They could also be in liquid form, and also solids, again, all at room temperature. It could be anything, a solid, liquid, and gas, depending on pressure and temperature. Here we're looking at generally that room temperature at 1 atmosphere. Those nonmetal chemical properties, well, they tend to form negative ions or share electrons. The high electronegativity due to the high nuclear efficiency allows nonmetals to gain electrons, forming anions, such as chlorides we see here, or they share electrons in covalent bonds or in networks. They also tend to form acidic or neutral oxides. Nonmetal oxides, like carbon dioxide or sulfur dioxide, often form acids when dissolved in water, or are neutral, such as with carbon monoxide. Lastly, they have a high electronegativity, which is a strong tendency to attract electrons in bonds, especially those halogens, fluorine being the example of the most electronegative atom. Now our metalloids, as I said, they're kind of in this little stair step, and they're bordering our metals and our nonmetals. They often have variable luster. They can have some metallic sheen, but may also kind of appear dull. They can be brittle or lack that malleability and ductility, breaking like nonmetals when they under a stress load. They typically are semiconductors, which is an intermediate electrical conductivity, which increases with temperature, unlike metals. They have moderate melting and boiling points. So again, if we're looking at the extremes of our metals and nonmetals, well, we're kind of in between. They often have high, due to covalent network structures. So silicon's melting point is 1,410 degrees Celsius, but lower than metals in some cases. There's also moderate densities, and these are typically between those metals and nonmetals, indicating their location in the periodic table does match between metals and nonmetals, so do many of their properties as well. The chemical properties of our metalloids, they have this kind of behavior that can act as metals or nonmetals depending on the conditions. So this anamorphic behavior allows them to kind of change depending on what conditions they're in, and that could be temperature and also pressure. For example, their oxides may form weak acids or bases. They can form covalent or mixed bonds. They tend to form covalent bonds like nonmetals, but can exhibit some metallic characteristics when in compounds. And they have variable electron behavior. They can gain, lose, or share electrons, again, due to this intermediate electronegativity as well as intermediate ionization. Now, the kind of summary table here to kind of border between the metals, nonmetals, and metalloids, it's probably best if you compare metals and nonmetals, because your metalloids, for the most part, are going to kind of fit in between those, both on the location within the periodic table, as well as many of the chemical and physical properties that they possess.